All right, so in this module, as you can see here, we're going to start to look at some examples of crystallography and particularly points, planes, and directions. So again, all this material in these modules for today is going to be review for a lot of you that have taken MSE courses before. So you can kind of skip through this and get straight to these questions. With the idea that if you can answer these questions, you probably can kind of go ahead and move on. So I've put all of these example questions in the quiz for this week. So if you want to, whenever you want to do these questions, that's fine. But please do it before you watch the videos, this video, which is going to go through and solve these with you. So if you can answer all these questions without the help of these videos, then you're all set, and you probably don't need to watch these, so you can maybe skip ahead and just deal with the issues that you're having for one of these problems. So that's what these videos are meant to be. We're going to work through the quiz questions, so please do the quiz questions before you watch the video. All right, for the first question on your quiz, in terms of example problems, it's relating to points. And so I've given you a certain structure. We haven't talked about this yet, but this is known as perovskite. It's an important ceramic structure. Barium titanate, barium titanium oxide, so BaTiO3, is one example of this type of structure. And we have a cube with points here represented by barium ions. And then we also have other points in this cube that represent the oxygen ions and the titanium ions in here. So basically, I want you to use our point coordinates to identify all the various points in this lattice. And so that's what you want to do with this problem. So for, let's start with the barium 2+. So these are the black points on these, and these are all of the indices, the vertices, sorry, all the vertices. So there should be 8, right? And if we call this point the origin down here, that's going to define as 0, 0, 0. And then we're going to have all the vertices. And so that's going to be 1, 0, 0. So if this is the x direction, y direction, z direction, then this point is 1, 0, 0, right? So that's where I get that. I can also look at this point over here as 0 in this direction, 1 in this direction, and then 0 up there. So 1, 0, 0, and I can do all of those as well. So I can do 0, 0, 1, which is that point up there. And then I can define the other one as combinations of 1, right? So if I look at this point, it's 1 in this direction, 1 in this direction, so I have 1, 1, 0. What else do I have? I have the, if I go 1 and 1, so that would be 1, 0 in this direction, 1 up here, so I have 1, 0, 1. And I'm also going to have 0, 1, 1. And then this last point up here is 1, 1, 1. So basically different iterations of 1s and 0s for all of those points is how I would get to that. And again, if you're struggling with how I'm getting this, we're designating an origin, and then we're drawing a vector from the origin to the point. So if this is our point, and then we're looking at the indices of x, y, and z, or a, b, and c, with relation to that line. So in this case, it's 1 unit in the a vector, and then 0 in the other 2 vectors. And so that's what I get. So that r vector, if I want to write it out in full, would be 1 times the a direction plus 0 b plus 0 c, right? And so I would put 1, 0, 0, and that's where I get this. I'm only writing those integers down. All right. So now if I want to look at the oxygen ions, sorry, that should be a minus. If I want to look at those, now I'm looking at these points. Hopefully it's clear from this drawing or the one that you've seen in the quiz, but these points are on the faces, right? So it's on that face or this top face, right? And so it's in the middle of each of these faces. And so the way I get to those, so let's focus on this point over here. The way I get to this face, it's right in the middle. So I go halfway in the x direction, 0 in this y direction because it's right on the axis, and then halfway up the z direction, right? So that would give me 1/2, 0, 1/2. So you can see that since they're in the middle of a face, there's going to be a lot of 1/2 in these indices. So I have 1/2, 0, 1/2. I have 1/2, 1/2, 0. So that's going to be, again, 1/2, and then 1/2, and then 0. So this is the bottom one. I can also have 0, 1/2, 1/2. And then I can start using 1. So 1/2, sorry, 1, 1/2, 1/2, 1/2, 1, 1/2, and then 1/2, 1/2, 1. And so just to kind of show you where some of those come from, if I want to look at, for example, the point up here, then I would go, this is going to be 1/2 in the x direction, 1/2 in the y direction, and then 1 up to the top point, right? Because it's on this top face, so you have to go an integer value up there. So that's where I get the 1/2, 1/2, 1. And so you can do that for all the other faces, 1 unit away from the origin. So that gives me that. And then the last one we have is the titanium ion. And that's 1 point right in the middle of the unit cell. And so that will be very similar. I'll have one, you can, it's right in the center of the cube, so you'll know that I'll have 1/2. So if I go 1/2, and then another 1/2, and another 1/2 up, that takes me to this midpoint, and that's the vector between the origin and this midpoint. And so I have 1/2, 1/2, 1/2. So I'm thinking of the basically these values here, and I'm translating in the x, y, and z direction by those increments to get to the endpoint of that vector, which is where that point is. So that's kind of how I'm doing this first problem. All right, this next example is looking at directions. So the first part, we're going to determine the indices. Sorry for the focus here. We're going to determine this indice of the direction shown in this unit cell, and we're also going to sketch, and we'll see the connection between those two. So let's go ahead and start with determining the indices of this red direction that I'm showing. So like I said before, I kind of always make this table of x, y, and z, right? And in this case, I'm for for directions, I'm always thinking about what we call projections. So the length that we travel in any given amount. So the translation in x, y, and z, or you can think of that as the projections. So in all the cases, when I'm looking at this unit cell, this is ideally my origin. That's where I started. But I also mentioned that the choice of origin is arbitrary, right? And so to determine the indices of directions, we always start at the origin. So it makes more sense if I move my origin, and let me do that in a different color. If I move my origin for this problem up here, and I'll call that O prime, just so that you know that it's different, right? So I'm going to have my origin up there instead. So now if I think of that as my origin, and then this is my endpoint, right? Now I can project what these indices are going to be and look at their projections. So in the x direction, so again, that's, now this, and then this is the same, right? So in the x direction, you can see that the direction goes to this back corner. So it actually doesn't go in the x direction at all, right? It doesn't go forward from the origin. It only travels along this back face. And so that is going to give me 0a. So 0 times the a vector. In the y direction, though, it does go from the origin over here 1 unit to the end. The end of this unit cell is 1 unit. So that's going to be 1 times the b vector. And then lastly, if I'm looking in the x direction, or sorry, the z direction, it starts at the origin. It doesn't go up. You can actually see it goes down. So it's going to be negative, and it's going down this z direction by half a unit. So this would be a whole. So here in the middle, it's half. So at 1/2, and that's going to be the c vector. So those are my projections. And so, because again, this describes the end point, where this point is in relation to this origin. So all I need to do is basically put this in terms of indices. And again, this is where I have to take into account all of those conventions that we use. So you'll notice that I have a fraction here, which is not an integer. So I want to multiply in this case so that I get the lowest integer. So if I multiply everything by, so if I multiply this whole thing by 2, then that would still give me 0 here. It would give me 2 here, but then it would give me -1, right? So I have the lowest integer possible here. It's not a fraction, it's an integer. So these are my indices, and so the indices for this direction I would write as, so again, it's important here. So square bracket means direction, so I'm going to write 0, 2, and I write the negative as a bar over the 1. So I'd read that as 0, 2, bar 1, and that's the direction that is represented by this line here. So that gives us the first part of this. So now it wants us to draw, and it gives us the 1, bar 1, bar 1, right? So we want to sketch this. And so for this, I'm going to draw a new one. I'm going to draw a new unit cell so we can start over. So when you're doing your homework at home, you can. I always try to give these in the homework statements. You can print these off. You can do it on the computer, whatever you need to do. But don't worry too much about drawing these if you don't have to. You can always print them off or use them on the computer, so you don't have to draw the unit cells here. But anyway, let's get back to this. So we have 1 bar 1 bar 1, which means 1 -1 -1. And so the way I'm going to do these types of questions is just in reverse of what I did up here, right? I'm going to make a table. I'm going to start with my indices. So I know my indices are 1, -1, -1. And then my projections, so these are the same, right? It doesn't matter whether you scale it or not. It just has to be within the unit cell. That was in the problem statement. It wants it to be within the unit cell. So it's got to be, the biggest thing has to be 1 or -1. If you have a number that's bigger than that, then you would have to do the division to get to something that's going to be within the unit cell. So that's really all you have to do. But this one is all 1s, and so we're good. So in this case, if we just start, this is my projection in the x-axis, so that would mean that I'm going 1 in this direction. But then you can right away see that I'm going to go negative in the y and z direction. So that would put me, again, if I go 1 unit here, then I'm going to go negative in the y direction and negative in the z direction. So here, the direction I'm going to draw is like kind of outside of here, and it's going to be hard to see. So instead of using my origin as the point here, I can choose a different origin such that this direction is within this unit cell. And so what I'm going to do is I'm going to pick one where the origin accounts for the negatives in the y and z. So basically, if I do that, I'm going to go this direction in the y direction, this direction, the z direction. It'll be up here. I'm going to call this double prime so I don't get it mixed up with the one up here. And that will, as you can kind of see here in a second, will account for the different directions. All right, so now if I start with this origin and follow these projections, I'm going to have, starting here, I'm going to go 1 unit in the x direction, which is along this. It's going to take me here. And I'm going to go 1 unit in the y direction, in the negative y direction, so that's going to be this direction. So it puts me over here in this corner. And then I'm going to go -1 unit in the z direction, so that's going to go down to this point. So this is going to be my final point here. Let me use a different color for you so you can see it. This is my final point. This was my initial point, so I can just draw a line between the two. Right? So that's my direction in this case, and it's going from this point to this point, and that's my 1, -1, -1, or 1 bar 1 bar 1 direction. All right, this example is going to look at planes, and so we're going to have a similar type of question where we're determining the indices of this plane I've drawn. It's also in the quiz as well, and then also we're going to sketch a plane in a blank unit cell. So let's start with determining the indices for this plane that I've drawn. And again, I always tend to start these problems in the same way, and it's to kind of do that table, right? So I have a table of x, y, and z, and in this case, since this is a plane, the first thing I want to do is determine the intercepts, right? That's going to be my first step. And in this case, again, we look at where the origin seems to be, right? The way I've drawn it, right? So the origin is down in that back corner like it kind of always is. And the first thing that we're going to see is that if I look at this plane, it intercepts the origin, right? So what that means is that my intercepts would all be 0, right? And that doesn't make sense. Having an origin, having the plane intercept the origin is a big issue. And so we're going to have to start with the origin somewhere different so that my intercepts aren't all 0, 0, 0, because that just, that doesn't tell us anything about the plane. So instead, and let me switch to a different color here. Instead, let's say that I pick this point up here as my origin, and again, I'm going to call that O prime. And in this case, I'm going to redraw a new set of coordinate systems based off of that origin. So this is my new x prime, or my new x-axis, what I'm going to call x prime, y prime over here, and z prime over here, all starting at this point, right? Because I want to look at the intercepts, but now I've changed the origin. So I'm going to look at it with reference to this origin and this axis system. So ignore the x, y, and z and focus on the x prime, y prime, and z prime. All right. So from there, again, looking at intercepts, if I look at my x-axis, so I'm going to change these as well so that you know that it's the primes. If I look at this axis and where the plane intercepts it, you can see it's right here, right? And so that is going to be 1 unit in the positive x direction, so 1 times a vector, right? If I look at the y prime axis and where that intercepts the plane, it's over here at +1 times the b vector, right? And then if I look at the z-axis, so this is the positive, you can see that it's actually going down, so it's negative z-axis, and it's -1 times the c-axis, right? So those are my intercepts with these various axes, so it's actually down here, which is negative. So I chose this origin. Again, I've chosen the origin so that it's very easy for me to figure out where my intercepts are. So my advice to you would be, you can try to randomly select one, but you might just kind of go through it quickly and see if you're going to be able to visualize those intercepts. Any origin should work as long as the plane doesn't go through the origin like it did here. The other part to that is the choice of your origin may make it easier or harder to see. I've chosen one where it's very easy to to work out where the intercepts are. If you choose something different, it's either going to coincide with the plane, or it might just be harder to find these intercepts that have been very easily with this origin. So that's just a kind of heads up on those cases. So I've got my intercepts here, and then you remember that the second part was the reciprocals, so 1 over the numbers for the second part. And let me switch back color. So if I do 1 over 1, that's going to give me 1. 1 over 1, again, that gives me 1. 1 over -1, it's -1, right? So the reciprocals didn't really give us much there, but those are what the Miller indices are. So essentially the Miller indices are the same here, so 1, 1, -1. So, and again, the way I represent that plane is with parentheses, and then 1, 1 with the Miller indices, and then the negative is a bar over that. So this is how I would write this plane. Right? So find my intercepts. The trickiest part is going to potentially be selecting an origin that makes it convenient for you and doesn't go through, the plane doesn't go through the origin. So I had to move it here. And then take reciprocals and then display it as a plane with parentheses, no commas, the bar for a negative. All right. So when we get to the second one, it wanted us to now sketch this 102. So I'm going to do the same procedure, but in this case, so I'm going to draw a sort of table here, and these are my Miller indices, right? So 1, 0, and 2. So if I want to get intercepts, which is how it's going to these are my Miller indices. Let me just write it out for you. If I want to get my intercepts, then it's still going to be taking a reciprocal, right? So if I take my reciprocal of these numbers, reciprocal of 1 is still 1, reciprocal of 0, so basically this is going to be infinity, right? That's 1 over 0 is infinity, and then reciprocal of 2 is going to be 1/2. So basically my intercepts, so these are also my intercepts down here, it's going to be 1, infinity. So what this really tells us is that it doesn't intercept the y-axis, right? And then lastly, it's going to intercept the z-axis at 1/2. All right, so I do this first and then I can sketch it. So let me draw a quick unit cell here. This is the x, y, and z axis. This is my origin here, like we've done before. And now we've already got our intercepts. So it intercepts this x-axis at 1. So I'm going to draw a point. It intercepts the y-axis at infinity, which means it doesn't. So I'm not going to draw a point there because it never crosses, excuse me, it never crosses that line. And then z, it intercepts at 1/2. So it intercepts this at 1/2 the value. So right here. So I have 2 points, and I know it doesn't cross or intercept the y-axis. So what I'm going to do is connect the points. In this case, I only have 2. But I know if it doesn't intercept the y-axis, it's actually going to be parallel to the y-axis. So I can draw a line from each of these points, right? And I know that the plane is going to run parallel. So this plane here runs parallel to the y-axis, therefore it can never cross. That gives us the infinity. So this is how I kind of shade and show the plane. If I had one more point, so if it did cross all 3 axes, I would have 3 points, and I could connect those points and draw my plane in that way. So that's how I sketch. So basically, if you sketch, you're doing the opposite procedure of determining the indices and vice versa.